Solving rational equations. So this is the last new stuff. Tomorrow we're going to start the next unit so that Friday we can do the review of this stuff, which will also give you a couple of days to do this. So tomorrow we do the new stuff. When would you have to get tomorrow's homework done by?
On Monday.
Yeah, Monday night, right? After the test. Then you can worry about the homework. So tomorrow we finish that lesson. Then you can work on rational expressions, right? You can work on this unit. Then Friday, we got the whole period for review. So you're going to want to have done some so you can come in with some questions, right? And then Monday will be the test, which cover everything. So everything that was on the quiz, plus adding and subtracting, plus solving, which is what we're going to do today. So a rational equation, in order to solve, you need an equal sign. Okay, no equal sign, no solution. Solution is a value of x that makes this true, right? So we're going to say, well, okay, if x is, we solve this, we come up with a value for x that makes it true. We make sure that that x value isn't one of the non-permissible values, right? So that's something we definitely have to check. So here are the steps. Factor all the denominators completely, which is pretty much if you just did that every time you saw a rational expression, you're on the step to doing something, right? Whether it's add or subtract, equivalent rational expressions, we want to factor denominators, state the restrictions from the factored form of the denominator, determine the lowest common denominator, right? Even for adding and subtracting, we do that. Now here's where we vary. What we want to do in solving a rational is get rid of the denominators, right? We need to lose them to just get a linear equation or a quadratic equation, right? All on one line, no denominators, nothing to worry about there. So we multiply both sides of the equation by the lowest common denominator, and both sides, but another way we can say this is multiply all terms. Okay, so like this is a term, this is a term, this is a term, or this, and this. They're all the terms. We're going to multiply each term by the lowest common denominator in order to divide it out of each term, right? So that will get rid of it. We then simplify each side. Okay, so we're now going to have an expression we need to simplify. Then we solve the equation. If it's linear, we're just solving for x. It could be quadratic. We're solving, again, for x, but it might have an x squared. And we'll verify that the solution satisfies the original equation. Okay, so it just means is a solution too. What might not be a solution? Well, we may have an extraneous root. So a solution that is one of the non-permissible values, right? So we're always going to state the restriction. Then we get our solution, and we look back and say, oh, wait, it can't be that because that's a restriction, right? It says that x cannot equal 2 or whatever. There are also inadmissible solutions. So it's a solution that's permissible in the original equation, but not valid in the context of the problem. So we're solving for the width of a rectangle or something, and we get negative 12. Okay, widths can't be negative, right? So we cross that out. Or you're solving for the cost of something, you get a negative cost. Okay, again, costs can't be negative, we cross that one out. So those solutions, which are solutions to the original problem, but not a solution in the context, are called inadmissible. All right, we're going to start off by just doing a couple of verifications. Okay, so we're going to verify if each stated root is a solution to the equation. The way that we're going to do verification is to do what's called a left side, right side. It's in a t-table. So what you do is just make a little table like this. Say the right side of this equation is 3. The left side is x plus 5 over x minus 1. And then we want to work each side separately, which in this case isn't that hard with the right side because there's nothing to do. So we're going to put in the value of 4 into the left side and work it out. But what we don't want to do is stuff like when we solve equations, we don't want to add 5 to both sides, so we're keeping the sides separate. So it's 4 plus 5 over 4 minus 1, which is 9 over 3, which is 3, and that's the solution. Okay, because that equals the right-hand side, so therefore x equals 4 is a root. And a root is just another name for a solution, right? It's the root of the equation, it's a solution. Yeah.
How do you get the 4?
It's given.
Oh.
Right? So we're not solving this. It's been solved. We think the answer is 4. We're going to try it out. This one, possible roots, +2 or -2. We think, right? Or we're given. Somebody solved this and they said, hey, here are the roots, right? It's + or -2. We need to verify. So again, left side is x over x plus 2 minus 2 over x. Right side is -2 over x plus 2. Okay, so there's that negative sign in front there. This time we're going to substitute. We're going to start off by doing 2. So we're going to say x equals 2. So it gives me 2 over 2 plus 2 minus 2 over 2. Which is 2 over 4 minus 1, or 1/2 minus 1, which is -1/2. Okay. Now we've got to try the right side, because the right side also has an x value in it. So it's a negative of 2 over 2 plus 2, which is -2 over 4, which is -1/2. So that checks. That's supposed to be a check line. That happened last time. Okay, so go back. No. Why are you doing this? Oh, whatever, okay. There, check mark. Yes, that worked. We want to try -2 now. Left side, x over x plus 2 minus 2 over x. Right side, 2 over x plus 2. So -2 over -2 plus 2. Okay, wait a sec. That's 0. And you can't divide by 0, so this is undefined. And -2 is actually one of the restrictions. All right, so if somebody said to you the solutions are + or -2, you would reject the -2 and just say that's a non-permissible value, right? It's a restriction. X cannot equal -2. If it does, we get a 0. And so there, we're just going to stop the check there. We don't need to go any further. Okay, questions on verify? So left side, right side. Work them independently. Just substitute in the value that you think is the solution, and then away you go, and you verify. I'd say at most it could be like 1 on the test, or we say solve and verify, where you have to show the verification. Okay. You still may want to verify, but there's ways to do it just using your calculator, right? You just sort of plug it in and just say, yeah, it works, right? Or just throw the number into the expression, like, oh, what if for that one x is 4? Well, that gives me this over this. Yeah, okay, that's right. All right, here we go. So let's start off. So, factored form, yeah, it's already factored, right? There's nothing to factor here. What's the restriction? That's 1. Have a little faith in yourself. Change just because I write stuff down.
Well, believe that you know better.
Well, I don't know nothing. How much of this have we done? How many mistakes do I make? And they're not even on purpose. The ones on purpose, I always like pause and wait for somebody to say something. The ones not on purpose, I keep going because I don't know that I made a mistake. You know, eventually I'll figure it out, right? Because you get to the bottom and it's kind of like, huh? But, you know, if you can find it before then, that makes things a little bit nicer. Okay, so what were the steps? State the restrictions. Yes, determine the lowest. What's the lowest common denominator? Oh, do this. There. We'll give the 5 its own little denominator, right? 2. I don't think so.
Or roll of x equal 2.
What's the lowest common denominator?
X minus.
X minus 1. Yeah. That's actually the only denominator, right? Only one denominator. So we're going to multiply both terms. There are actually only 2 terms here, right? By x minus 1. And let me see if I clean that up. So x minus 1 over 1 times x plus 3 over x minus 1 equals 5 over 1 times x minus 1 over 1. Brackets all around. Okay, so we're going to multiply every term by x minus 1. Now, when we do that, on the left side, these guys cancel. Top and bottom, right? X minus 1s. And so now on the left side, I've got 1 and 1 as the denominator. And on the right side, I've got 1 and 1 as the denominator. And that's what I want. I want a denominator which is all 1s. Okay, because it means that we basically got rid of the denominator. So this term here is x plus 3. And this term here is
5x plus
5x minus
5.
5. Yeah. So we're just going to multiply, right? Distributive law. 5x minus 5. And then we just want to solve this now, right? It's just an equation.
I don't get why you're multiplying everything by x minus 1.
To get rid of the denominators.
Okay.
Okay? But to maintain equality in an equation, as long as I do the same thing to both sides, it stays equal. So I'm multiplying both sides by x minus 1. Right? That maintains the balance. Right? Because if I just say, oh, let's multiply this by x minus 1 and do nothing here, they're not in balance anymore, right? So we got to do it to both sides. And both sides, I mean all terms. So when we do that here, we're going to take this one, and this one. Okay? Because really multiplying this side by something, you still have to use distributive law. So I'm going to just sort of shortcut that and just say, we're going to multiply each term by, which gives us the same result. Okay, so let's move this over here and this over here. So I'll get 8, right? I'm going to add 5 to both sides, right? Minus 5, add 5. Subtract x from both sides. So what's x? 2.
I did it the other way and I just got x's
Oh, you're wrong.
negative.
Well, it's not negative 2. If it were negative 2, I'd get negative 1 over negative 3, which isn't 5.
But couldn't you move it on even both sides? I took the x.
Okay, then you'll get negative 4x is equal to negative 8, which gives you x equals 2. You get negative 4x equals negative 8. Gives you x equals 2. We check the x equals 2 against the restriction. It's not a restriction. If we want to check, 2 plus 3 is 5. 2 minus 1 is 1. 5 over 1 is 5 over 1. So it checks, right? Do not check on Monday until the end. In other words, finish all of the problems, and then if you want to go check solutions, then go back and check your solutions, right? But it's more important to do the work, because if you start checking, if you get it wrong, then you start erasing, fixing things and stuff like that, and that takes a lot of time, which you may not have, right? It could be time that keeps you from doing other questions. And it might just be you're going to lose a half a mark, right? Even though you're wrong, it's only a minor mistake, which costs you half a mark or a mark. But if you go back and you erase it and you start redoing the whole thing, you could lose 3 or 5 marks later on. You just don't get to finish the test. And so check at the end. You got time at the end, then go check. Factor. It's in factored form already, right? Let's just write the 6 as a 6 over 1. And let's say that a cannot be 0. Okay? Most of the time on the test, be like the quiz, we will not ask you to state restrictions, right? But there'll be the odd question where we say state the restrictions. Okay? Restrictions, generally be worth half a mark for the restrictions, and it's kind of all or nothing. Right? I mean, if you have too many restrictions, you're going to get nothing. If you have not enough restrictions, you're going to get nothing. You need just right. It's got to be, the Goldilocks and the 3 bears. Not too hard, not too soft. It's got to be just right. Not too hot, not too cold, just right. What's our lowest common denominator? 2a squared, right? We need a 2, we need an a squared. So we are going to multiply every term by 2a squared over 1. Okay, so I'm going to go 2a squared over 1. I just like that because then it looks like a fraction, right? And we can multiply. Times 3a. Or sorry, 3 over a. Times 3 over a. Minus 2a squared over 1 times 6 over 1 equals 2a squared over 1 times 5a over 2a squared. Okay? So we'll do a few of these kind of the long way or whatever, and then I'll show you a shorter way, and you can choose which way you like. Okay, so we'll sort of pop back and forth, and if you don't get the shorter way, then I'll be happy to do it the longer way. Right? I mean, it's not a big deal. Okay, if we've done this right, then all the denominators are going to disappear, right? So this a takes out the a squared, right? And it just becomes an a. These are 1s, so we don't do anything. This 2a squared divides that 2a squared out. So now in the denominator, we should have 1, 1, 1, 1, 1, 1. And we do.
1, 1, 1, 1.
All 1s, right? So we don't want any denominator. Now we're just solving a quadratic or a linear equation, which are generally fairly easy to solve. Like linear like this, that's very easy to solve. So what do we get? 6a minus 12a squared equals 5a. Okay, so make sure that you look at that and say, yeah, okay, I see where everything came from. It's all good. You can trust me, but I wouldn't trust me too much. If we bring this over, we'll get negative 12a squared. I'm going to subtract 5a, so it'll be minus a is equal to 0. All right, so the way that we solve any equation is to get one side equal to 0. Right? And now how do we solve this? Well, we can factor out an a, or maybe a negative a. Might be better to factor out, right? Let's factor out negative a. This will give me 12a, right? Because I need to get negative 12a squared. And this will get me plus 1, because that would give me a negative a. Okay, you could factor out an a as well. It doesn't really matter. Yep.
Would that be a positive a? Like on this negative 12a squared minus a, would it be positive?
Negative
Because you're
plus
subtracting
positive is
plus.
negative.
All right, right, subtracting 5. Okay, so let's do this. It's good. It says, if I made that mistake on purpose.
But this wasn't on purpose.
I know. But I can pretend it was. See, and now we know Thomas is with it. He's on top of this. So hang on, I think that 6a minus 5a is positive 1a, and he's right. Okay. So now that means that a is equal to 0, right? We need this times this to be 0. It's like doing non-permissible values at this point, really. This solution is really like just doing a non-permissible value. Yeah. Only
But
it's
it
not.
can equal 0.
Yeah, I know, eh? So then we reject that solution. Good. That wasn't a mistake on my part. It was something we were going to do. Okay, so here's what happened. The act of multiplying through by 2a squared introduces extraneous solutions, right? That's what it says at the top of the page about this whole extraneous solution. So the method that we use to solve this by getting rid of denominators will sometimes introduce solutions that are not allowable. So we got to state them. We got to say a equals 0, right? Because that's part of the thing. But then we have to say, wait, that's a restriction, so now we're going to cross it off. So it won't be part of our answer. Yeah.
What should you write on a test when you get something like that?
Exactly that.
Okay.
Yeah. You should write it, and then you should cross it off.
Okay. So we don't.
And what's the other solution?
A equals 1 over 12.
Yeah, 1 over 12.
What do we have to be? Yeah.
And this one, you put something out, right? So what I want to see if it's a determiner, even if it's multiple choice, it's like, who cares, right? I mean, the choices will be like 0 and 1/12, and some people will pick that one and it's wrong, and the choice will be 1/12, and some people will pick that one and it's right.
At the step where it says 6a minus 12a squared equals 5a.
Yep.
I understand how you got rid of the 6 by subtracting the 5, but what about the 12? Does that just stay the same?
Okay, so the a squared term, there's no other a squareds in here, right? So the negative 12a squared, there's nothing we can do to it. Okay, the 5a we subtract, so 6a minus 5a, as Thomas pointed out, is positive 1a. Okay, and then that's it, right? So there's no a squared term to collect with that a squared. So negative 12a squared just stays. You see where it came from, right? The 2a squared times the negative 12a squared comes from this, right? Minus, and then you multiply those two together. Okay? But there are no other a squared terms, so there's no further simplifying. We get a equals 1/12, a equals 0. We cross off the 0, say it can't be, that's the restriction, and circle that or square that or whatever, box it up and say, here's your answer. Okay, any questions? All right, can I select that and shrink it down?
CBE.
Don't want that. All right, don't know what to do. All right. Okay, next one. Let's factor. 1 over, what's the factored form of 2x plus 8?
2 bracket x plus 4.
Right. So remember, when you're factoring a binomial, you're always going to have 2 terms in the brackets, right? Because it has to expand back out. And I would say anytime you factor something, just do a quick multiply it out, right? 2x plus 8. Okay, good. Equals 16 over.
2 bracket x minus 16.
Right. Okay? And here's the other, one of the really major reasons to check when you factor a binomial that you got it right. If you get it wrong, like, because we're not just factoring, right? Like in 10C, it was all about factor this, factor that, and the whole question was just factor. This is, once it's factored, then we're finding lowest common denominators and multiplying stuff, or we're making common denominators, adding and subtracting. So if you do a factorization wrong, the whole rest of the question is going to go very badly wrong for you, right? And very badly wrong doesn't just mean you're going to get the wrong answer. It means it's going to take you 5 minutes to get that wrong answer, right? Because you're going to have created something that's way more complicated than it should have been. So always check and just make sure that, did I factor that? Yeah, okay, I get 2x plus 8. I get 2x minus 32. Now, some of you are saying, can you cancel this 2 with this 16? And you can, but we're not going to. So you said, I didn't even notice that. Well, it wouldn't have hurt you in this case. And I'll tell you why we're not going to cancel it. What's the lowest common denominator here?
2x plus 4, x plus 16.
Minus 16, right?
Minus 16.
Yeah, so we need a 2, we need an x plus 4, we already have a 2, we don't need another one, and we need an x minus 16. So I'm going to multiply through by 2 times x plus 4 times x minus 16, right? There's 3 things.
Then we have to multiply all the numerators by?
That's what we're going to multiply all the numerators by. Well, sorry, we're multiplying every term by, okay? And there's not much space, so I'm going to try and do this the short way, right? So here's how it's going to work. So just watch and see, and if it makes sense to you, then just go, okay, yeah, good. I see that that's what you did and why you did what you did. So first of all, non-permissible values or restrictions. Yeah, -4 and positive 16. Okay. Now, here's what we've said. The lowest common denominator is this, right? It consists of 3 terms, a 2, an x plus 4, and an x minus 16. When I multiply it by this, the 2 and the x plus 4 take each other out, leaving me with just what?
X plus 16.
You keep saying plus, but I know you mean minus. So this term is just going to simplify to 1 times x minus 16, right? Just imagine this gets put in front to multiply it, and we're crossing this off, and we cross that off, so we just get 1 times x minus 16, right? On the other side, I've got a 2 and an x minus 16, so it's going to take out these guys,
So it'll be x plus 4, 16 times x plus 4.
so it's 16 times x plus 4. Okay? Does that make sense? And it's a lot less work than I didn't even have the space to write it out, right? Otherwise we'd go 2 times x plus 4 times x minus 16 over 1 times 1 over 2x plus 4, and then cross off the 2x plus 4.
What happened to 2?
2's gone, because the 2 cancels with the 2 times x plus 4. Okay? So we're multiplying by this. And when we do that, this 2 and x plus 4 are gone, leaving us with just this. When we multiply this side, this and this are gone, leaving me with that, right, which is crossed out from before. So this is what we get. X minus 16 equals 16x plus 64. Okay, so we solve that. It doesn't really matter. I'm going to take the x over here, so I'll subtract. So this will be 15x. Take the 64 over here and subtract. So it'll be negative 80. And so what's x equal to? Negative 80 over 15, right? And now I'll show you the easy way to do that on your calculator. The secret I have withheld from you until now.
That's not good.
No, at some point you should learn this is now the point. So that if you do multiply monomials together and get 360 over 144, here's how you get it simplified. So here's how you simplify. What do we got? Negative 80 over 15, right? You go negative 80 divided by 15. Now you could hit enter, it'll give you a decimal. So instead I'm going to hit math, enter, which says take negative 80 divided by 15 and convert it to a fraction. And reduce it while you're at it, right? So give me the reduced fraction, which is negative 16 over 3. So x is equal to negative 16 over 3. Okay? So if you had that 360 over 144 needed to reduce it, I think we had one. I'll get to you in a sec. You would just go 360 divided by 144. Now if you hit enter, you get 2.5, and then you hit math, enter, it changes it to 5 over 2. Okay, so on the test you have to reduce monomials and they're big, just put one over the other, go math, enter, boom, done.
Math, enter, boom, done.
Yep, math, enter, boom, done.
We'll get the second step.
The second step. This one?
Yep.
Okay, anybody else? Not gonna, I'll just go through it with you after.
Okay.
Okay, everybody else, good? Okay, just to show the actual thing takes a lot of space, and I can do that for you after when we have some room. Yeah?
Show the longer way?
Well, now that 2 people have asked.
Okay. I just
The longer way, all right, let me just,
It was on this page.
I need a new page. Insert blank page. Okay, what was the question?
1 over 2 over 8, 2x plus 8.
No, it's 16 over... Okay, this is where we were, right? Okay, I'm going to multiply every term by 2 times x plus 4 times x minus 16. I like to put it over 1 so it looks like a fraction. And I'm going to multiply that by 1 over 2 times x plus 4. I'm going to multiply 16 over 2 times x minus 16 by 2 times x plus 4 times x minus 16 over 1. I'm going to cancel. The 2's cancel. The x plus 4's cancel. The 2's cancel. The x minus 16's cancel. In my denominator I have 1, 1, 1, 1, 1, 1. And up top I have 1 times x minus 16 and 16 times x plus 4. And that's where we go to the other page because the rest of it is just from that point. Okay? So that's just a quicker way to get there. Okay, so that you can get there from here, that's just a faster way. Okay, so 2 more of these, and then we've got some word problems. And we're going to do a bunch of word problems, but there won't be a bunch of word problems on the test. There'll be one or two.
Awesome.
Okay? And Jenny will take you by the hand and lead you through them on the test, right? Because word problems are not, you know. So it's just, you need to do a number for homework, right? You need to come in on Friday and ask about some of them, right? Well, I tried this question, you know, this is what I've got, and that's not the answer or whatever. I don't understand this, that, or the other. I'll be around Monday before school, right about 8. Oh, wait a second, is badminton practice on Monday? I think they do. No, yeah, they do.
Monday?
Yeah, so then I'll be here
It's not
before
badminton,
8.
It's with hockey.
Badminton. I'll be here Monday before 8 o'clock, so if you need some help in the morning, right, at lunch you can pop into Henry's and ask for help, and you're writing after lunch, right after lunch. Right after lunch. Okay, what can't x be for this? It's all factored, right? There's nothing to factor. So what can't x be? 0 or negative 1. All right. What's my LCD?
What's LCD?
X plus 1.
And x, right? So just look in each, once it's in factored form, just look in each denominator, right? All you do is you say, okay, I need an x. I need an x plus 1, because they're different, right? Like if x were 10, this would be a 10, this would be an 11. Those are obviously different. So I need an x plus 1. If we go back to here, again, once we're in factored form, everything's off now. Once that's in factored form, I need a 2. I need an x plus 4. I need a 2. No, I don't need another 2, right? I already have a 2. I need an x minus 16. So the easiest way is just to go through the LCD, or through the denominators, and find, just say, need one of those, need one of those, oh, and let's call that a 1. Don't need one of those, right? Don't need a 1. Okay, what are we going to do? We're going to multiply each term. Okay? Short way. We'll do the short way, then we'll do the long way. So short way is to say, okay, I'm multiplying by this. The x's are going to take each other out, and I will be left with 4 times x plus 1 plus 6 times x, because the x plus 1s are going to take each other out, equals 6 times x plus 1. Okay? Now I'm going to do the long way. Okay, so I just want you to see this, because we're going to end up at this line. It's just going to take 2 lines to get there, which is fine, right? So for anybody that can do this in one line, great. You know, it's quicker, it's easier, and that. But if you want that one extra line, then I will show you what that line looks like. Okay, so let's just pop down to that blank page, or this page, which. Okay, so what we're dealing with, 4 over x. All right, so hang on. So here's what we're going to do. We decided that the lowest common denominator was x times x plus 1. And we're going to multiply that by 4 over x. And then we're going to take the common denominator, which is x times x plus 1. And multiply that by 6 over x plus 1. And we're going to take the 6 over 1 and multiply it by x plus 1, like that. Okay? So in this one, this is a line you could insert above the line we just wrote. And it's just saying we're going to take the lowest common denominator, multiply it by every single term. And there are 3 terms, right? 4 over x, 6 over x plus 1, and 6 over 1. Okay? 3 terms. Now we cancel. So this x takes out this x. This x plus 1 takes out this x plus 1, right? And whenever we cancel, we just write a 1. And nothing happens here. So all my denominators are 1. So we have 4 times x plus 1. We have 6 times x. And we have 6 times x plus 1. So we have 4 times x plus 1 plus 6 times x and 6 times x plus 1. Okay? So short way, long way, your choice. Don't do it if you're not comfortable with the short way. Don't do it the short way, right? I mean, all you're doing is saving a little bit of pencil lead and some space on a page. And it's not worth getting something wrong to save a little bit of pencil lead and space on a page. I have lots of paper, or you can bring out scrap paper, right? So if I don't give, you know, if you write large on paper, then just do your work on a separate sheet of paper. On the test page, just write C attached, and when I come to mark that question, I will go look for it on the attached piece of paper.
Can I go to dojo?
You need these six.
No, 'cause I have to go.
Because you have to go?
And I can't.
Right?
Sorry?
You need the 6x times x.
6x times, yeah, that's what we're going to do. So let's multiply this out. So we get 4x plus 4 plus 6x. Okay, just treat this as 6x. Go ahead. Okay, so we're going to take 6 times x, just treat it as 6x, and what's that going to give us then? 6x squared plus 6x, right?
Why wouldn't you do 6 times x, then 6 times x, and then 12x? Why?
6 times x is 6x squared. 6 times x plus 6 times x is 12x.
No, the first 6 times x,
Mm-hmm.
shouldn't it be 6x times x? Because it's a 6x up there.
Oh, you're right. Yeah, sorry. That's a 6x. So that's a 6x squared. You're right. Right. Let me go fix this on the other page then. There, 6x. Good catch. See? Wow. I'm just not having a good day. You should have seen me this morning. It's far worse than this. Okay, so life will be now easy and simple, right? Because what we're going to do is subtract 6x squared from both sides. And we just cross them off, really. What you're doing is just saying, let's subtract 6x squared from both sides, so they're gone. So now we get 4x plus 4 equals 6x. Let's move this over. We'll get 4 is equal to 2x, and so x is equal to 2, which isn't 0 or negative 1. And we'll just pretend it's the end of the test now, and I'm going to go check this. 4 divided by 2 is 2. This will be 12 over 3, which is 4. 2 plus 4 is 6. Okay. Now, I mean, I just say that, and you just go, huh? You know, it's true. But you do it on your calculator or something, right? And you would take a little more time doing it. So do that at the end of the test if you want to. I think x is 2. Let me go check and see if it is. All right. Let's write that over 1. Because I like things to look like fractions, look like rational expressions. Non-permissible value. Just 1. Remember, non-permissible value is the value of x that'll make that 0, right? So I put a negative 1 in there, I get negative 2. So check your NPVs too, right? Or check your restrictions when you're thinking of it. Just say, negative 2. Wait, that'll give me negative 4. Okay, positive 2. Right? And then you'll avoid that. And you know you do that, right? So then you really want to make sure that you check that. And just say, you know, let me make sure I've got my sign correct here. LCD?
X minus 1.
X minus 1. Okay. We'll do this the long way because why not? I mean, it's not a big deal. And I'm going to go x plus 2 over 1 times x minus 1 over 1. So we're multiplying, in this case, both sides, because there's only 2 terms here, right? There's the left side and the right side.
Would you use FOIL then?
Nope. You would say, oh, here, yeah, now you're going to use FOIL. Okay, so on the left side, the x minus, so what we're looking for is in the denominator, 1, 1, 1, 1, 1, 1, 1, 1, right? Just 1. However many denominators there are. In this case, there's 4, right? So 1, 2, 3, 4. Okay, everything's good. Left side will be 6 minus x. Right side is binomial times binomial. We need to use FOIL. We're going to get 4 products. It will collect into 3. We will then have a quadratic to solve. because there's no way to get rid of the squared, because there's no squared over here. Like there's 6x squared both sides. Get rid of them. Okay, so we get 6 minus x is x squared minus x plus 2x minus 2. Simplify the right side. You get x squared plus x minus 2. And if you want to multiply this out and go directly to there, that's fine. That's what I would do normally. Okay, so we're going to subtract 6 and we're going to add x squared to both sides. So x squared plus 2x, right? Add x to both sides. Subtract 6, that'll be minus.
Wait, what'd you do?
Okay, so we need to get one side equal to 0. Anytime we're solving an equation, it's got to be something equals nothing, right? Or, expression equals 0. So to do that, since I have a positive x squared, and I like positive x squared,
everything from that side over to that side?
I moved everything from left side to right side. So I added x to both sides, and I subtracted 6 from both sides. So what's that expression equal to then? The x squared plus 2x minus 8. 0, right? And so I could write 0 equals, but I prefer equals 0. I just like it on the right side, not the left side. And we will squeeze in. This will factor. It is x plus 4, x minus 2 equals 0, giving us answers of x equals negative 4 and x equals positive 2. Just write that where we can read it. You're not going to have a ton of this to do on the test, but you may have to factor a trinomial, right? It'll be fairly simple like this. Two numbers that multiply to 8 differ by 2, 4 and 2. Bigger one is positive, okay? Anytime you factor, check, okay? Whether it's factoring binomial or trinomial. So just multiply this out, right? X squared minus 2x plus 4x. Minus 2 plus 4 is plus 2. Minus 8, okay? Usually you're going to get these numbers right. You're going to get the 4 and the 2 right. What will happen is you'll get a negative there and a positive there. If you're going to make a mistake, it's going to be you flipping your signs. So just do a very quick multiply out and say I'm subtracting 2 and adding 4, that's adding 2. Okay, so my answer, this is 0 when x is negative 4, this is 0 when x is positive 2. Okay, now I'm going to erase that because it's in the middle. But I'll just write it up here. X equals negative 4, positive 2. Compare that, not a restriction. Won't give us 0. When you go to check it, if you go to check it, you'll end up with, 10 over negative 5, which is negative 2, and you'll get negative 2, and you'll end up with 4 over 1, which is 4. So they both will check. Okay? When do you check? At the end, when you're done everything, right? So finish everything off. Then if you have time, you can go back and start checking some stuff. When you're writing the test, do the easy stuff first, right? I call it cherry picking. I mean, just go through the stuff. There's going to be stuff that you may have walked in Monday morning and said, how do you do that one? And then there it is on the test. You go, I just asked about that. I know how to do this one. There's going to be stuff you're going to look at and you're going to say, wow, that's going to take a lot of work. So I would leave it until a bit later. And there's going to be stuff you look at and go, I must have missed that day. Although I don't recall being away, this looks like nothing we did. Leave those until the very end as well. Right? Because otherwise they can just be a real time waster because you'll just spend too much time trying to get it. So go in and cherry pick. Do the easy stuff first. Then do the stuff that you know is a bunch of work. Oh, it's solving one of those equations. That's always a ton of work. I'll leave that until later after I've done the easy stuff. Okay? And then I'll go back and if I have any time, I'll look at that one I didn't even recognize.
Can I go together actually?
Sure.
You should go to.
I don't have to go that badly. And how quickly it goes depends on how fast you walk, how hard you push. Oh, damn, it's recording and everything. Oh. Competing in an endurance race, Shannon cycled for 120 kilometers, then swam for 12. Her average cycling speed was 8 times faster than her average swimming speed. If Shannon's average swimming speed is x, write an expression for her average cycling speed. So she swam at x, how fast did she cycle?
8 times faster.
8 times faster, so
8x.
8x. We're going to use this info. So she cycled for 120 kilometers and swam for 12. Those are distances. Her speed of swimming was x, and her cycling speed was 8x. Okay? So we're just filling the table in, what we know. Basically, we could have done the 120, the 12, and the x. And then 8x because they told us that she cycles 8 times faster. Write an equation that represents Shannon taking 9 hours to complete the race. So remember, we did a couple of these yesterday, right? But we couldn't solve them because we didn't know the amount of time or anything. This time we do. But how are distance, speed, and time related? What's the formula?
Kilometers an hour, x kilometers per hour. That's
Okay.
the swimming speed.
But how do I rate? How do I just forget it? How do you relate distance, speed, and time? Distance equals speed times time, right? I'm driving 100 kilometers an hour to Edmonton for 3 hours. I will go 3 times 100 or 300 kilometers. So distance equals speed times time. But we want time. So what's time equal to? Distance over speed, right? Okay, so distance over speed. 120 over 8x and 12 over x, right? Distance over speed. All the distance, speed, time problems pretty much work like this. Okay? You have a known distance that you went, or they might say that they were the same distance, right? So then in that case, it's just a minor variation of this. You get a speed, but you get a relationship between a couple of speeds, right? It's either 8 times faster, or maybe she cycles 10 kilometers an hour faster than she runs or something, you know, something along those lines. And then time is distance over speed. So the equation we're going to get is the time that she bicycled plus the time that she swam is equal to 9 hours. Okay, remember time is measured. In this case, time is measured in hours. Now we want to solve this equation. So first thing, denominators are factored. X cannot equal 0, which in the context of the question is also true. Obviously, she's not going 0 kilometers an hour, right? Nor could she, because she wouldn't get anywhere. So we're not worried about a restriction at this point. But if we get a negative answer for time, or for x, then we need to reject that, right? She's not going backwards. Okay, what's the LCD? 8. 8x. We're going to multiply everything by 8x. So 8x over 1, I'm just going to erase that, times 120 over 8x plus 8x over 1 times 12 over x equals 9 over 1 times 8x over 1. This 8x and this 8x divide out. This x takes out this, leaving us with an 8 there and a 1 there. Denominators are 1, 1, 1, 1, 1, 1. We're left with 1 times 120 plus 8 times 12, which is 96, is equal to 9 times 8x, or 72x. This is nice. It's a nice linear equation. Right, it's 216 is equal to 72x. And x is equal to 3.
Wow, you're so smart. How do you figure this out?
Because I did it this morning. Also, come on. 3 times 70 is 210, and 3 times 2 is 6, so 260. So Shannon, who's actually Katie, right? Oh no, it's Shannon. What?
Nope. Or is it Jimmy the fish?
Jimmy the fish. All right. I'm gonna use something different. I don't know. This morning's okay. Never mind. So it's got Katie next. It's got Katie next, and then C and D of Katie or Shannon. Actually, guess what the new principal's name is?
What? Katie?
Jimmy?
You could call him Jimmy, I suppose. But formally, it's James.
I have an uncle named Jim or James.
But he goes by Jim. I don't know if he goes by Jimmy, but if you call him Jimmy.
I feel like
Scott.
I get.
Why is it not a gal?
Those guys are the best.
No way, you guys suck.
Okay, Shannon's average swimming speed, her average swimming speed.
I just went to kickboxing class in gym. I get tossed in the elbows.
I just ran some field hockey with my field hockey stick.
Field hockey stick. I break it.
Field hockey.
Okay, if you want to check a word problem, the way I do is I go back to the original statement. So I say, okay, competing endurance race, Shannon cycled for 120 kilometers. And so her average cycling speed was 8 times faster. So we know her cycling speed is 24
Why was he talking
because we're checking it.
about?
So she cycled for 120 divided by 24, which is 5. She cycled for 5 hours. She swam 12 in 3, which is 4 hours. And 5 plus 4 is 9. Okay, so then it all checks out. All right, only 3 more to go.
I know you.
Okay, this is where Shannon should become Katie. Or Jimmy.
Jimmy Cross.
When are we meeting, Jimmy?
Tomorrow.
I don't know.
I feel like we're
Quick question.
Yeah.
To the solving.
Yes.
Huh?
Shannon all the way, not Katie then Shannon.
Okay, it says, the equation was 120 over 8x plus 12 over x.
Yes.
equals
9. Yeah.
But when you're taking out the like terms, like why did we use the 8x plus x? On the bottom was the x because.
Hang on. Katie is cycling and running. Katie burns 125 calories more when she is running compared to when she is cycling. In one workout, she burns 690 calories on her bicycle, burns 690 calories on her bicycle, and 1,260 on her run. Katie burns X calories per hour when cycling. And how many does she burn when running? X plus 125, right? She burns 125 more.
How do you know that?
So there's going to be a relation in the, it's just like Shannon's swimming speed was 8 times, or her cycling speed was 8 times faster. So one of these is going to be a variable, and the other one of these is going to be some variation of that variable, right? Like 2 times it, or X plus 125, or whatever. So it could be like 2 cars, right? One car's going X, the other car's going 10 kilometers an hour faster. Its speed would be X plus 10. One car's going X, the motorcycle's going twice as fast, its speed would be 2x. Right? And then we look at the times. So here we've got time. So use the info to complete the table. So what's an expression for time here?
Age?
Well, the H is
Or
hours.
would it be like, rate of calories burned times total, no, times time equals total calories, and then I can manipulate it?
Okay, so then what's time?
Time is calories divided by. I don't know.
Calories divided by the rate at which they're burned, right? And this one is 1260 over x plus 125. Now, if you're not sure, that's like, how do I know it's 690 over x? Why isn't it x over 690 or something, right? So think about it this way. You're putting calories, the 690, calories divided by calories per hour, right? Because that's what that's in. Which becomes calories times, and then we're going to flip that, right? So hours per calorie. And then these guys cancel, and we're left with hours, which is a measure of time. Okay, so we want calories divided by calories per hour, which will give us hours. Write an equation that represents Katie working out for a total of 3 hours. So what's it going to be?
3 equals 690 over x plus 1260 over x plus 1.
Yeah. So the time cycling, 690 over x, plus the time running is equal to 3. X cannot be 0, but it couldn't be 0 anyways. X cannot be negative 125, but it couldn't be negative anyways. right? So there are restrictions, but we don't really need to concern ourselves with them on this because they'd be inadmissible anyways, right? You can't burn 0 calories per hour unless you're dead. Then you're burning 0 calories per hour, right? Any living organism is going to burn some number of calories per hour. You know, even a hibernating, whatever hibernates, bear or something, would be burning calories, right? Very slowly burning calories, but they got to fatten up so they have enough calories to burn off over the winter, right? Anyways, any organism will be burning, it won't be 0 and it won't be negative. Okay? There's no negative burn rates. All right, LCD.
X plus
X
125.
plus.
X and X plus 125, right? So both of them. So I need an X plus 125. Okay, short form solution. The 690,
Oh my god, I'm so
the 690 is going to be multiplied by X plus 125. The 1260 is going to be multiplied by X, and that's a plus sign. Plus the 1260 will be multiplied by X, and the 3 will be multiplied by both. Okay, it's a short one. If you want to, you fill in the long one above. Leave yourself a little bit of room to fill it in,
Do we have a
and then
second to do the long one?
sure. I'll give you time. Well, I'm giving you time. Oh no, well, something will be missing. Oh well. 10x squared minus 20. Okay, wait, let's simplify this a bit here. So here we'll get 110x. Now it's not writing.
Plus 20x.
Hang on, gotta wait for the ink to refill. 110x plus 900 equals 10x squared minus 20x. Okay, so 10x squared minus 130x, right, move the 110 over, minus 900 equals 0. We'll squeeze it in here. Everything divides by 10, right? So we can do that. So x squared minus 13x minus 90 is equal to 0. Two numbers multiplied 90 differ by 13. Let me start with 1. 1 and 90. Now they differ by 89. 2 and 45. No. 3 and 30. No. 4 doesn't go in. 5 and 18. Oh, yeah. Now if you don't know 5 and 18, does you just go 90 divided by 5, and when the 18 pops out, you go, hey, 18 and 5. I can get a 13 out of that. So it's going to be x. The larger number will be negative.
What do you do with the 10 that would be on the other side?
Just divide both sides by 10, and 0 divided by 10 is just 0. So I don't even factor it out. When I solve an equation, I don't factor the 10 out. I just divide everything by 10. Okay, so x equals 18,
It can't be negative.
and x equals negative 5.
It can't be that because that's
And you're going to cross that off because you didn't buy a negative number of t-shirts. So there were 18 t-shirts in the case. 450 divided by 18 is what she paid. 560 divided by 14 is what she got. Difference is 10.
what time is it?
Oh, don't worry, there's still time.
8 minutes.
Yeah. There's not much time, but this one won't take long to do. One more, I thank you for your patience. It's just this unit, I think. They're not all like this. I went to Ms. McKay and I said, are they all like this? Like, I thought this was shorter. We had a couple of days, right, where they were just 45 minutes, but so no, they're not all like, just this unit is just, you know, got a lot of stuff to do. Okay, two sisters. This is another common type of problem. It's a rate at which people work problem. So we know that people work at different rates. Maybe you have a sibling and, you know, one of you gets sent out. So here's Amy and Britta raking leaves in their yard in the fall. Amy takes X minutes to complete the raking if she works on her own. Britta, who we'll say is probably younger, takes 25 minutes more if she's working on her own. If they work together, it'll take them a half an hour to complete. Okay, so two people working together should take less time than each individual. So, what fraction of the raking is done in 1 minute by Amy alone? What's her rate of work?
X.
And that's not.
Okay, so if Amy took 30 minutes, which we know she doesn't, what fraction of the work would she do each minute?
130.
1/30. So if she did it in
X.
1 over x, yeah. So it's the rate of work. It's she'll do 1x of it in each minute. It takes her x minutes to do. If you add up 1 over x plus 1 over x with x times, you just end up with 1, which is the whole task. So 1 over x. How about Britta? She's going to be,
1 over 25 plus x.
yeah, so 1 over x plus 25. Working together, the fraction of raking done in 1 minute will be,
1 over x minus 30.
well, so they're working together, so we've got this. And how much of the work will they do each minute if they're working together? What fraction of the work?
But you don't know how long it took them to do it on this.
Yeah, together they can do it in half an hour.
So we'll do 1 that's it.
So 1 over 30, right? If you can do it in half an hour each minute, you're doing 1/30th of the work. Right? And then 130 plus 130 plus 130 plus 130. You do that 30 times, you get 30 over 30 or 1. You've completed the whole job. Okay, we know that x can't be 0, nor can it be negative 25, whether that's mathematically or
Are we
contextually.
supposed to solve it?
Yep, fraction of raking done in 1 minute for both of them working together. And then if you look at the bottom, oh, doesn't it say to solve? Really?
Yes, we don't have to do that.
Nah, I still want to solve it. But I'll solve it for you. You can just copy this down.
Okay.
Common denominator is 30x and x plus 25.
Why is it 30?
Because you got a 30 in a denominator, so you got to take the 30. Okay, we need a 30, we need an x plus 25. $30 and an x plus 25. $30 and an x. So 30s. Okay, I'm just going to extend the page, or not. So, there you go, solution.
Does that say 5? Oh, 50.
Negative 15, sorry. Squeeze the negative. So working on her own, Amy can do it in 50 minutes. Working on her own, Britta can do it in 75 minutes. Working together, they can do it in 30. So if you add 1/50th plus 1/75th, you'll get 1/30th. Okay, so tomorrow we start exponential. That homework you won't need to do until Monday night. So after the lesson tomorrow, got time to work on, if you have any time to work, working on rational expressions. Friday, rational, so you want to do some tonight, want to do some rationals tomorrow night, and then you want to consolidate anything over the weekend to get it all figured out. And Monday is the unit test. Next unit, no quiz, just a homework assignment. No, I think you should do it on your own. Or maybe with one other person. Yeah. I'm going to get 2 that are identical anyway, so. I'll let you decide if you want to work in partners
Yeah.
for the homework assignment. No, one on the orange sheet. Instead of a quiz, there's a homework assignment.
It's always a good day.